Hey everyone, welcome back to another episode of the Works Plus Grinder series. Last week was a big one, and so was the week before. We talked at great length about the grinder heads, all the different things to do with the belts, the bearings, and pretty much everything inside one of these heads. And if you're like me, you're kind of sitting there going, just show me the grinder already. Here's a little bit right now. But we're getting a bit ahead of ourselves. I'm sitting here going, show me the grinder already, but if you're listening to all of the input, you'll probably get a good idea of how much work and expertise has actually gone into designing this new grinder. And hopefully you can fully appreciate when it comes out what's actually built inside all of these machines, just how much thought, how much expertise and consultation has gone into it. At least I'm hoping that's what you're taking away from it. Otherwise you're just sitting there going, give me the new grinder already, which is kind of what I'm really doing internally. Anyhow, today we're wrapping up the discussion about the head. We're talking about all things to do with ratio sizes, a couple of little tricks that Tim and Hayden have got up their sleeve if they want to use them. We're also going to be talking about 3 heads versus 4, so listen in. I think this is going to be a good one.
So Tim, I feel like this is the 3rd episode.
The 3rd installment of the heads.
Did Josh wake up from the last one?
Kind of thing that put you to sleep.
Well, what's left? What have we got left?
Well, I guess it's kind of an elephant in the room that we haven't really talked about, and that is, it's been pretty clear, I think, from some of the pre-release information that we've been putting together, that clearly we've put a 3-head machine together. It's not a 6-head machine, it's not a 4-head machine, it's not 8, it's not 15, it's not 2. It's the boring old 3-header.
That's right.
So I guess probably we should start off talking about why we've gone with a 3-head.
Look,
Since we're talking about heads.
Josh has got the answer for that already. It's because apparently I can't count to more than 3, according to Josh. So that's why
Okay.
that's why I haven't done a 4-head, because I can't count that high. So why have we stuck with this?
Well, I guess we've covered a lot in the grinder series beforehand, where Josh and Brando were doing the different road testing of the different machines. We talked a bit about the 3 and the 4-head configurations and I think the benefits of it. Clearly there's benefits to both machines, but at the end of the day you need to make a decision on which one you want to go with and why. And I guess probably to keep the conversation really short, our feeling over the years is that a 3-head machine is probably just more versatile across a wider range of applications and let's call floor flatness levels. So we like the 3-head machine for that reason, but clearly there were some very good reasons for 4-head machines as well. And probably the one thing about the 4-head machine I'd probably want to touch on today, because it's very related to what we're about to talk about, is we haven't just gone for a 3-head machine, we've gone for a 3-head machine with some fairly big discs underneath of it, okay? And anyone that's used let's call it one of the major platform floor grinding machines, will be pretty familiar with either the 3-head, certainly very familiar with the 3-head machine, but also a 4-head machine. And probably one of the key things that is relevant to our conversation today is that the space between the discs underneath the machine. So we've got a round head grinding machine. Obviously it's a circle. That circle has a certain amount of square centimetres or inches or whatever your language is, your unit of measure. And that's all obviously under the cover, rubber skirt, whatever it is around it. Okay, so there's a certain amount of floor area that head of the machine is sitting on. Now, the actual percentage of the floor that is in contact with the grinding disc is substantially less with most machines out in the marketplace.
Correct.
And clearly, if you've got, say, an 800 size or a 32-inch size machine, with pretty common to have like a 270mm, which is 11 inch, something like that, 11.5-inch disc. The distance between the actual discs underneath the machine, there's a gap. So there's a disc, then there's a space, there's another disc, then there's a space. A bit like this this space here. And what that means is as these discs are turning around on the floor, there's always a point in time, and it's if we took a snapshot, where there's only a percentage of the floor that's in contact with diamond tools at any time, okay? Obviously, the bigger the big drum or the big head is and the smaller the discs are, the bigger the space is in between the discs, and therefore the greater the amount of surface area on the floor that's not actually in contact with diamonds at any given time.
Yep.
So what I like about the 4-head machine is it introduces that 4th disc, and essentially what that's done is it consumes more of the real estate underneath the machine. So as far as contact surface area, amount of tooling in contact with the floor, and effectively the percentage of the floor area being worked on at any particular time, it's higher under a 4-head machine than it is a 3-head machine.
Yep.
So that's a pretty important sort of consideration and takeaway, I think.
Absolutely.
Now, having said that, go back to our previous comment, was we think the 3-head machine is more versatile and has more benefit in balance.
Yep. Across a broader range.
Across a broader range, and that's why we've committed ourselves to the 3-head machine. However,
we've made some changes.
We have made some changes because we want to actually try and address some of the deficiencies that we were talking about just a minute ago about the amount of surface area that the diamond tools or the discs of the machine are in contact with the floor at any given time. So tell us a little bit about what we've done to make the best of that scenario while sticking with a 3-head machine concept.
Primarily, I guess we've made the discs as large as we, I guess, effectively can under the machine. So the surface area of where the discs are and the gap in between is quite minimal. Again, there's restrictions on how big that can be based on the diameter of your machine. But in essence, we've calculated and gone, all right, what is the biggest disc we can do? However, that also ties into what size fly pulleys and centre drives you have. There's a whole other aspect to, not just going, hey, let's go and put this gigantic disc on there, because we've got to drive it somehow. And the bigger the disc, the more load is going through everything.
So clearly the bigger the disc, okay, and I guess one of the things that people really need to understand with this type of machine is that they're not running all the time. Okay, they are a static start machine. We've talked about the weights of the machines and how things are getting heavier in previous episodes. All of that weight sits on heads. Those heads are sitting on the floor in a static parked scenario. Pretty much any time before the machine is started up. It's not like they're started up off the ground
and lowered
down. No, they're started fully loaded. So from a startup torque point of view, the heavier you make the machine and the bigger you make the discs, the more starting torque you make. Okay. So like you're saying, the consideration that goes, okay, we want big discs because we're covering a bigger part of the floor or a big portion of the floor, a bit like the 530 the grinder, the old PG 530. Big discs covered a lot of the floor compared to the 680 and the 820. So we've kind of incorporated that sort of thinking into this machine, but of course, big discs mean thing needs some torque. Okay.
Correct.
Like you mentioned, there's always trade-offs with these machines. We're always, almost building one of these things with a hand tied behind your back because we've got a defined size or chamber that all our parts need to fit into. And of course, to drive a big disc, we need torque. Torque comes from the ratio basically between the big flight pulley and the centre drive pulley that's on the motor of the machine. So going back to the 4-head discussion that we just had a minute ago, clearly putting a 4th head in here, again, restricts the space that we have to work in and the dimension that we can make these pulleys. So another reason why we've gone with the 3 over the 4 is it gives us a much bigger opportunity or range of options as far as that ratio between centre drive pulley, flight pulley, and of course the disc that it's driving.
Absolutely, and also the way the belt is fitted inside as well with your belt wrap. As soon as you add a 4th pulley in there, you start losing some of that wrap that's gripping on that pulley to give it the drive mechanism as well. And reducing everything down, smaller Fly pulleys means to get the same torque rating, you need a smaller centre drive, which then, like we were talking about the other day, certain belt materials can only wrap a certain amount.
Yep.
So there's a whole, this all is just a float-in, move-in area of what you're choosing.
Yeah, and of course last week we talked about minimum pulley diameters, basically how small a pulley you can flex a belt and its joint around.
Yep.
Clearly there's also a minimum amount of belt wrap you need as well, right? And you just touched on that. The more parts you have in, the harder it is to route a belt around pulleys and still get enough wrap to deliver that power without slippage and still be able to get that torque from the motor to the floor.
Correct.
So they're all the moving parts, or they're all the different sort of equations that we're trying to deal with here.
Correct.
So let's just talk about this ratio here between the centre drive pulley and the fly pulley to start with.
Yep.
Okay, because that's a really important ratio. And we've seen lots of different machines through our workshop. We've pulled them open and we've seen that sort of ratio. What are the sorts of things that we've seen? Because we've actually made quite a database when it comes to
Different machinery.
the motor that they've got, centre drive pulley, the fly pulley and the disc. And we've been able to boil that down to one magic number, if I could call it that tells us essentially how much drive power or torque power is at the diamond tool. That's what it comes down to at the end of the day.
Correct.
What sort of power are we getting out of this tool? Because that's what we're
needing to get
That's what we're driving at the end of the day.
Yeah.
We started off this head discussion about this is where the rubber meets the road, or where the diamonds meet the concrete in our industry. And this is the thing that does all the work. Everything else is a support act to the head.
Yep. As Tim said, we've done a bunch of calculations working out from the different manufacturers. And there was a fair variety out there. Obviously, you go from your early Gen 1s, which we're very familiar with. When you move up to the Gen 2 machines in the Huskies, there was a difference in those machines. It wasn't a smooth across the board increment. There was a few major changes in there that that would have hindered certain parts of the operation of that machine. But also moving to other manufacturers, there's no magic number that everyone's grabbed, but it's generally speaking, I think most companies are running a smaller centre drive than what we are. Part of that reason would be motor size. Most of them aren't running the size motor we are, because that's essentially what the centre drive is bolting onto. So if you don't have as much power there, you need to shrink down on that in size. I'm not sure if that's the answer you're looking for here, Tim, but...
Well, the other key ratio is the size of this fly pulley to the disc.
Versus the disc,
okay? Because whilst there's a step up in ratio between the centre drive pulley and the fly pulley, what we call a fly pulley, there's then another ratio, which is the ratio of this pulley up to the disc that's driving. So it's basically two ratios stacked on top of each other. And at least as far as we're concerned, the closer that we can make this fly pulley to the size of the disc, the less loss there is, or reverse ratio. I don't know what the proper physics terminology is for that. Probably if I was an engineer, I'd have a better technical term for that. But essentially, the closer we can make this pulley to the size of the disc, the more true we keep the ratio between the centre drive pulley and the fly pulley itself.
But of course, we don't want them exactly the same either.
No, we don't. Why not?
Well, there's this wall that goes in here somewhere, and somehow I don't think, it'll quite work, to get this pulley to the same size. But this has got to sit inside the cover to get out as far as we can to the edge of the machine.
I was going to say, because we could actually make this disc smaller than this fly pulley, okay? That would be very advantageous from a torque point of view.
It would be, yes.
But then we can't grind so close to the wall anymore. So clearly we want with the disc as big as possible, at least so it gets out to the edge of the cover of the machine. So we can get a nice sort of maybe half-inch
along a wall,
12 mil in our language, up to a wall or even closer. And of course, again, the bigger we make that disc, the more advantageous that becomes for grinding close to the wall, but we start having to drive a bigger disc.
Correct.
And that's why this ratio. One of the key things, I guess one of the cool features on this machine is pretty much, we've always worked with a set ratio between the fly pulley and the centre drive pulley. And if we wanted to change that ratio, it's a bit of a major task on any other machine to change that pulley out.
Yes.
So one of the things that we've done essentially is made that removable. So effectively, you know, I can't remember, this is like a 2.5 to 1 ratio or something on this machine right now. We've got 22 kilowatts of power, which we've got a very powerful motor on this machine. So it gives us lots of options just because it's got 22 kilowatts of power. But, you know, if we want to go down to a 2 to 1, we can drop a bigger centre drive pulley on here. If we want to go to a 3 to 1, we can go to a smaller centre drive pulley there. So that's a really easy thing to do because that's a removable centre drive pulley. So from an R&D point of view, from a testing, it enables us to really
quickly and easily test different ratios.
I guess my final comment on the whole ratio side of things is we just mentioned before that at the end of the day, we're talking about driving a diamond tool. And when it comes to driving a diamond tool, one of the key considerations is the linear speed.
Yes.
Okay. So let's just have a little bit of a chat about linear speed and how all what we're talking about here affects the linear speed of the diamond.
Well, effectively, where the diamonds are placed on the disc, obviously quite towards the outside, the smaller the disc, the slower the revolutions, I guess, or the revolutions are the same, but the distance travelled around changes, which is what your linear speed is. So the further out and the bigger this disc goes, the faster the diamond tool is actually running.
So essentially, for one RPM, because the circumference on a bigger disc it's a bigger distance than, say, if it was a half the size disc. It's still 1 RPM, but in the two different circumstances, the diamond has to travel a lot further on the big disc in the same amount of time. So the linear speed, or the metres per second, or whatever that diamond is doing, is higher on a big disc. Okay. So when we come to talking about diamonds and the linear speed, clearly we've got a range of opportunity with this machine because of the size of the discs and moving those diamonds at a higher speed if we want to. And like we mentioned, we can alter all that because we've got a variable ratio we can set up here. We've obviously got for the frequency inverter, which we can speed up and slow down the motor. So this design opens us up to a range of opportunities from a diamond linear speed, diamond tool linear speed, which we haven't been able to do in the past either.
Correct. Absolutely. Is that going to be a benefit?
Well, I don't know. Look, the general rule of thumb is we've always, in all of our training, we've always told people, how fast should I be running my discs? I mean, that's kind of like how long's a piece of string, because every machine, even between the manufacturer, you can have a 680 and 820. There's a different ratio here. There's a different disc size. The diamonds their linear speed are different. So it's not a simple answer, but I guess the answer I like is that we have the opportunity to do things with diamond tools which we couldn't do in the past.
Bigger range of opportunity.
Probably the other thing that's really important with this format that we've come up with is having a bigger disc means we can put bigger tools, more tools under it, particularly when we're seeing a lot more products like Tempo XD being used out in the marketplace. So tools that are sensitive to weight, and a lot of weight, in the previous machines that we've had experience with, there's only so many you can put under a disc until you've maxed out, because there's just no more space to put a diamond tool. We can actually put more tools on this, which means that we can essentially we can build tools of softer bonds, where there may be an advantage having a softer bond tool, but of course
you've got more.
Traditionally, that would wear out quickly because you can only put so many tools under a machine. Now we can put more surface area of diamond tooling under there, maybe a softer bond, get a completely different type of performance because we're running higher diamond speeds. We have those abilities to actually experiment and play with. Have we got there yet and tested all those things? No, we need something for next year.
That's right.
And the year after. But again, it's really opening the doors to possibilities that we just haven't been able to do in the past because we've just been limited by the geometries of the machines.
There you go. Nice sneak peek for everyone into what's to come.
Yes.
So Tim, have we forgotten anything? You know, people who might be falling asleep already, you know, if we watched all three in a row, is there anything left? Are we putting this one to bed? Like, are we?
When it comes to the head,
Yeah.
it's a bit of a head scratching question, that one. I think now, Hayden, we've probably covered the most of it.
Most of it? Not all of it, but
Not all
most
of it. Not all of it. We keep on dreaming up new things to talk about, but certainly from let's call it the key features, the key considerations, and the final product. Even though, like we've mentioned, there are some variations we can still incorporate. Yeah, I think we've I won't say we've flogged this one to death, but we've certainly given it a good go.
Okay. Good. What's next?
What's next? Well, I think we deserve a couple of weeks off.
Couple of weeks off? Yeah, all right. Well, we better wake Josh up and let him know.
How is that for size? That is awesome. Well, that was intriguing and pretty short. So hopefully that means we're getting a whole lot closer to seeing the big reveal. Catch you next time, guys.